Adam!
All right. Good afternoon, ladies and gentlemen.
What's up?
We're going to go over these. We have quick review exercises 1 through 10. So these are based on what you should already have encountered at some point in your algebra career. So we're just going to go over this today. So the first one we have, exercise 1 through 4, solve the equation or inequality. We have x squared minus 16 equals 0. Any hints on this one?
Plus 16.
You add 16 and then you square root the x squared and 16 is over on each side.
Okay. Okay, I could go for that. Okay, x squared equals 16. Okay, and next you say square root
Square root?
of both sides. Okay, so we take
X
square.
equals
That's 4.
4.
Is that our answer?
That's
Yeah.
right. That is our answer. That's
Is
not
something,
our answer.
so are we missing something here?
Yeah.
What are we missing?
Inequality.
Well, that's an equation, not an inequality. Girl.
We'll be doing inequality later, yeah. What is this? This is a partial right answer. What's your answer?
Circle it.
What's your complete right answer? No, that's not it.
Oh.
You guys knew this last year.
Squared minus.
You knew this last year, but you forgot. But you forgot.
Oh, you check it.
No, no. That is a good idea,
It's
though.
how you
Check
write
it.
it.
This will work for normal teachers.
Kayla, you've already done all of it.
Well, it's not exactly hard, Kaylee.
That's
Is it x equals 4 and x equals negative 4?
Okay, there it is. Thank you, Will.
What?
X equals 4 and negative 4.
Plus or minus.
Or that.
Plus or minus. So somebody remembered it. Good job, Will.
No, you still have Will here.
Now, the thing about it is, this is a tricky problem because what happens when you're first learning how to solve square root equations, they were to solve Pythagorean theorem, right? In Pythagorean theorem, do you have a negative number as an answer? No, you don't. Well, that's something that we do need to think about when you're in precalculus and beyond, okay? Good work. Okay, this one right here. Take a minute and work this one out. I think Kayla probably already has.
I got it.
No, I just haven't done it.
Okay, what you should get for this one, Kayla showed it to me. Your answer to this one should be x is equal to plus or minus 3.
That's what I got.
You know,
I got that.
right that I was writing it.
Okay, that's fine. One thing I want to do also is I want to show you a different way of solving this problem. I could have showed you on number 1. So let's go ahead and let's move this 9 over here and move this negative x squared over here. So we have a 0 is equal to x squared minus 9. Does everybody agree that we can do that? Basically, when you move a term on the other side of an equal sign, you change its sign. And that's a good operation right there, okay? So instead of setting one side equal to the other like we did on number 1, what else can we do to this right side of the equation here? Can we factor that quadratic binomial?
Yes.
How would we factor that?
X minus 3x plus 3.
Very good. All right. Very good. So you got x plus 3, x minus 3. And now what do? Set each of these factors equal to 0. So that's called the zero factor property of algebra. And so we have, therefore, x is equal to negative 3, and x is equal to 3, right? Now, what's the advantage of doing it this way versus the way we looked at number 1? There is an advantage. What's the advantage of it?
It shows that it has negative and positive.
Yeah, so you work it out, so you're more sure that you have a positive and a negative answer, right?
But the other way is shorter.
But the other way is shorter. And so it's like a pro and con deal, right?
Yeah.
So there are pros and cons to no matter which way you go. And so, good work, good work. Okay. Okay, we got this x minus 10 is less than 0.
X is less than 10.
X is less than or equal to 10.
X.
Less than or equal to 10, yeah. So if we add the 10, right? So we get x is less than 10, right? So that's all there is to that one. Now this one here, how would you solve this one? 5 minus x.
Minus 5, then times it by a -1.
Okay,
And
we
that
could
flips the sign, doesn't it?
Yeah.
we could do it that way. So we get negative x is less than or equal to negative 5. We divide or multiply the whole equation by -1. I'll multiply by -1, right? What do we get? We get x is greater than or equal to 5. Okay? All right. Now we get into 5 through 10. Find all values of x algebraically for which the algebraic expression is not defined. Support your answer graphically. That's one thing I forgot to do in 5th period, support graphically. How do we find where the algebraic expression is not defined? How do we get not defined or undefined in mathematics or in algebra? There's only one way I know of doing it. No, there are a couple ways, but the main way of doing it is what? How do we get undefined?
But not defined yet.
I don't remember that.
It has
It's
to
been
do.
too long.
It has been a while. I agree with that. It's been like since March. What do you do? What operation is undefined in mathematics or in algebra?
I don't know.
Infinite ones?
What can we, it has to do with 0. I'll try to,
Oh, find the 0.
X equals 0.
no. Now, if you put x equals 0, now that's a good thought. If you put x equals 0, you could do that, but you'd get 0 over -16. So that's defined. So the function is defined for x equals 0. What is the function not defined for?
We don't know. We forgot. We don't know.
Okay, if you have a calculator, what I want you to do right now, I want you to take 5 or any number and divide that number by 0.
It doesn't want to have a calculator.
And tell me what your calculator says.
Error.
So what can you not do?
Divide by 0.
You cannot divide by 0, okay? So what can x not be?
0.
No, x can be 0.
X cannot be 16.
X cannot be 16. So what it is, our basic answer is x equals 16, right? X cannot be 16. So we say x equals 16. Yes, may I help
I'm
you?
sorry for interrupting. Can I get your roll sheet?
Yes, you may have them. You may have the up-to-date ones right here.
Thank you so much. Appreciate it.
And to set up the equation for it, we can set it up as x minus 16 cannot equal 0. And so therefore x cannot equal 16. And so this is what x cannot equal, and so we want to find out what is not defined. And so our answer in terms of the way the question is written is x equals 16. Does that make sense?
Yeah.
Not defined for 16, but the way the question is worded, that is our answer. Okay? Now this one here, what are you going to do with this one?
Square root of 16.
So let's go ahead and take, what we do is we set x squared minus 16 cannot equal 0, right? If you set your denominator equal to 0, then you can solve for x.
Add the 16.
We can add 16, or we can do this business here, right? Right, so x
Does not equal
plus 4 cannot equal 0. X minus 4 cannot equal 0. So x cannot equal negative 4. X cannot equal 4. And so so this is what's not defined, so what is our answer here?
x equals plus or minus 4.
X equals plus or minus 4. Okay? Next. Okay, now we're dealing with a square root. So what do we do with this? What do we know about a square root?
You can square it.
You cannot square a negative number, because the number of times itself cannot be negative.
You actually can you, she said you cannot square a negative number, is that right?
You do the thingy.
That's almost
In
right.
calculator you can, but yeah.
Yeah.
Okay, the way it should have come out was this. I'm sure her intention was good. You said it should have come out something like this, Kenzie. Should have said you cannot square root a negative number.
Yeah.
She just forgot where to find.
Yeah, she did. She knew what she was saying.
I completely
I could
agree
tell.
with you.
Yeah, I could tell the way she was articulate. Yeah. So, how do we go ahead and set that up algebraically to work that out?
Multiply it by a negative number.
Yeah.
Actually, it was Chloe in 5th period who figured out what this was. How do we set this up? Well, you set it up that you know for cannot be negative. How do you write cannot be negative?
Equal slash.
It's equal to.
Okay, cannot be negative, you can write like this, right? Greater than or equal to. Because that greater than or equal to 0 means cannot be negative, right? Is that right?
Yeah.
Yeah.
That is correct.
So now if we solve this, x has to be greater than or equal to 16. So that's where x is defined, right? How do we tell where x is not defined?
Flip it.
Yeah, x is less than 16 is not defined. So is defined, and then the way the question is worded is this is not defined,
Yeah.
and so therefore this is our correct answer, okay? ¿Hay preguntas? No hay preguntas?
What?
Questions?
I barely speak English.
Pregunta.
You're gonna need a non-talking Spanish.
Ustedes me brincan.
What?
Yeah, you get other teachers. You get other teachers that are paid. You got other teachers that are paid to teach you Spanish, right? Why do I have to get involved? All right, that's a good point. Okay, now this one right here, 8. How do we work this one out?
This one looks difficult.
On the top part, can you just do,
You can just cancel it out because that's
Yeah,
what
can you cancel it out?
the one would have to stay inside.
Okay, let me ask a question, because I think Angel might be onto it here. Can x squared plus 1 ever be a negative number? Or no, it can never be a negative number. Can't even be 0. Has to be 1 or greater. So this thing is going to have nothing to do with limiting the domain of the function or the value here. But does the denominator have an effect? Yes.
Yes.
So we know that x plus 1, x minus 1 cannot equal 0, right? So where's the function? So we have x is not equal to negative 1, x is not equal to 1. So for what value is the function not defined?
1 and negative 1.
Plus or minus 1, okay? So that's number 8. Okay, now we're to number 9. So we're ratcheting up our complexity little by little on this, as you can see, I hope. So how do we handle this one?
Square it.
Square it. I don't think we can do that. We really can't square it. And why can't we not square it? Why can we not square it? Because it changes the value. It changes the overall value if we square both the numerator and denominator. Now, if we were solving one side, we could square it, but we can't square the numerator and the denominator. The only preservation if we squared both numerator and denominator is if they were both 1, I think, or if they were both the same number, whatever. No, how do we work this out? Look back at problem number, whatever that was.
7?
Yeah, look back at problem number 7. Yes, thank you. How would we set this one?
Greater than or equal to 0.
So this one right here, x plus 2 is greater than or equal to 0. Would that be one thing?
Yes.
So therefore, x has to be greater than or equal to
-2.
-2. So that's one condition, but do we have another condition involved
The
here?
bottom.
The bottom, right? And so how do we take care of that? 3 minus x what?
3 minus x plus.
Greater than or equal to 0?
Yeah. Oh, just.
Is that right?
Just
X
like
is less than or equal.
Well, it's less if it's flipped.
It'll flip once you.
But I'm just talking about writing it upright like this. Okay, you're working ahead. But what is this a good expression here right now?
Yes.
Yes.
It's a great expression.
No, it is not right. It's not right. What's wrong with it?
The x needs to be before the 3?
No, we could change that. That's not what's wrong with it. What's wrong with this expression here?
It shouldn't be or equal to.
Yeah.
Okay, yeah. So I think Hannah figured it out. Hannah, tell us why can it not be equal to?
I'm not sure about that one. I just had a feeling.
Because Adam says you cannot divide by 0.
Yeah.
That's why.
Oh,
So
yeah,
she
sorry about that.
had an instinct. So that's why it kind of looks the same, but it's not exactly the same, right? And so then you can solve it any way you want from here. If we add x to both sides, we have 3 is greater than x, which means x is less than 3, right? So now, how can we tell where the expression is not defined from these? Because these tell you where it is defined. How do we tell where it's not defined? Okay, what I did in 5th period, which I would do for myself, really, because to me, once you talk about is and not and reverse, it's easy to get confused, right? I get confused. So let's just put it on number line here, put our critical numbers here. So we get -2 here and 3, right? Is that what they are? So what goes here for the solution on the number line? What do we put here? Dot here,
And a circle on the end.
dot here, open point here, right?
Yep.
And then between the two is where the thing is defined, right?
Yes.
And the reason this is helpful to me is because you have to take these two conditions into account. And so now to answer the question where the expression is not defined, how do we get from here to where the expression is not defined?
X is less than or equal to -2.
He says x is less than or equal to -2. Is that right?
Ooh, it would be negative
Would it be-
2 is,
Yeah, it's going to be less than -2.
-2 is greater than x. And then.
Okay, why is it going to be? We have the point here, but why is what it's not equal to less than -2?
Oh yeah, it's less because it's negative.
Because we have to get everything except this dot, right? And also x can be not be what?
3.
Greater than or equal to 3. Okay, it looks kind of confusing, but what happens is, this is what it is. We have to, in these expressions, write down everything that this is not. And so it cannot be 3, so that means it cannot be 3, that means that 3, the equal sign, is undefined. So that's a reverse, so that one, I wouldn't know how to do that without writing down a number line and looking at it, frankly. Okay, here, the last one, how do we work this one out?
Almost. Essentially means the same thing. Easier learning.
Cancel out the x squared.
Could you do the problem?
Can you cancel out x squared? No, you
I didn't
can't.
ask you.
Okay, you take your denominator, x, we'll put a factor number, x plus 2, x minus 2 cannot equal 0. So x cannot equal negative 2, x cannot equal 2. So what is that going to be? What is our answer for this?
X equal to positive or negative.
Yeah, it cannot be either plus or minus 2. So that, ladies and gentlemen of pre-calculus, that's that one. Any questions on that one?
No, we got it.
Okay, good.